says boron has 2 naturally occurring isotopes. Just by that phrase, what is our initial setup going to look like?
2 parentheses.
2 sets of parentheses equal to something, right? Now, it says find the percent abundance of boron 10 and boron 11. So here we're finding 2 sets of percentages. So we can't just subtract this from 100 because we don't have anything to subtract from 100. Given the isotopic mass of boron 10 is 10.0129, the isotopic mass of boron 11 is 11.0093. Now, where would these numbers go in our formula? If these are the isotopic masses, where can we at least put those in?
In the last spot, the second spot.
Well, in the parentheses, right?
Yeah.
Now, technically, inside the parentheses, it doesn't matter if it goes first or second.
Oh, it doesn't?
No, because it's always going to be the mass
Oh, yeah.
and the percentage multiplied against each other. Whether the percent comes first or the mass, it doesn't matter. But we're going to put this one here, and then boron 11 on the second. So I'm going to actually do it up front. Okay. Now, what pieces are missing from this equation? What would this number technically represent? This is the what?
The average atomic mass.
Average atomic mass, which if it's not given to us and we're not asked to calculate it, where would we go to find it? Periodic table. So look at boron on your periodic table. Find the atomic mass of boron. Someone tell me what it is.
10.811.
10.811. Go ahead and put all the numbers that are on your periodic table. And then now what's left for us to find are these 2 percentages, right? Okay. Well, math terms, if we assign one x and one y, it's going to be really hard to solve for. So what we want to do is try to find a relationship between the 2 of them where we can at least have one variable. What are some things we know about percent abundances? For example, if I have 50% of this, what would this one have to be? 50, right? If I had 80% here,
20.
what would this one have to be? 20. Now, either one of these, what do they add up to?
100.
100. Okay, well, let's say that if we were to use these in decimal form, what would 50% be turned into?
0.5.
0.5. What would this one, 0.5? What would 0.5 and 0.5 add up to?
0.1.
1, right?
Or
Is that the same pattern here? This would be 0.8, 0.2, does add up to 1, right? So we've got 2 different patterns here. Now, do we typically use percentages in the math?
No.
No, we change it to a decimal, right? So what we want to focus on is if we know that whatever these percentages are in decimal form, they should add up to 1, right? So let's assign this as x. And if we know both of these together will add up to 1, what relationship could we possibly say about this one in terms of x that this one should be?
100 minus x.
Not 100 minus x, but if we're using the decimal form of percent,
Something equal to 1?
1 minus
1
x.
minus x. Very good.
Oh.
Now we have a relationship between these 2 that we have the same variable. For example, if this one was 0.8, we know that 1 minus 0.8 will give us that second percentage. That's why we can use this right here. And what we're going to do is insert these now into our formula. So boron 10 was here. This becomes x. 1 minus x goes here. That does need to be in parentheses because that will affect us distributing the number in front. And then now we have nothing more than an algebra problem again. So let's simplify what we can. This right here, if we take the parentheses away, becomes a number x, so 10.0129x. What happens here though? We have a number times a set of terms in parentheses. We do need to distribute. So this becomes plus 11.0093 minus 11.0093x.
And And
You
combine
didn't think
like
there was so much
terms.
algebra in this, yeah. So combine like terms, I'm gonna combine my x terms here. Everything else copies down the same. I've got 10.811 equals, what is 10.0129x minus 11.0093x? Because we're combining these two x terms. So 10.0129x minus, I'll let you do that. And if you say the number out loud, say it slow.
Negative 0.9964.
Perfect. And that's going to have the x term, right? So that, and then this is plus 11.0093. Now, if I want to isolate my x term, how do I get rid of the 11.0093?
Subtract.
You subtract it from both sides. Very good. Now, this cancels here, leaving me with negative 0.9964x. I'm going to work this out in my calculator. And by the way, this is the work that you would need to show on all these problems like this.
So on problems like this, are we always gonna have to do 1 minus x?
For a problem like this where they don't give you any percent abundances, yes, because that's the only relationship we can draw between the two. We know they're both going to add up to 1. So if we assign x for 1, we know the other one has to be 1 minus x. Now, you won't see a problem like this with 3% abundances because there would probably be a lot more. You would only be able to solve this like this with 2% abundances missing.
That is negative 0.19093.
0.19093. Perfect. Okay. Now, from here, how do we solve for x?
Divide.
We divide off the negative version. And x now will be, it's going to be positive because negative divided by negative is positive. And so when this is typed in, what do you get?
0.1916.
So 0.1996.
16.
Sorry. Now,
So then would we
hang on, real quick. Double check this minus this. So we should get 0.1990.
Okay.
Do 10.81 minus 11 point.
Answer.
0.0093. Is that number correct?
No.
Okay, tell me what that number is. Because
It is
I know what the
negative
final answer should be. Negative what?
0.993.
993?
Yes.
0?
No, just negative 0.993.
Okay. Now divide that number by 0.9964 and let me know if you get something different. That's better. Okay. Now, this x we assigned earlier to boron 10. Okay? Now this is in decimal form, so how do we get this decimal form back into percentage form? We move it to the right 2 places.
I didn't get that.
You should have gotten that is the correct answer.
I typed that in and it says I typed that in.
I think your first, when you subtracted 10 minus 11, your first number was wrong, because I got,
Yeah, it was wrong, so we changed it.
no, I mean like the second time you did it, because I still got a different answer.
10.811 minus 11.0093. Yeah, this should be
0.1983.
yeah 0.1983.
Why is that wrong?
Well, you did 0.81 instead of 0.811. So you got to type these in very carefully.
Okay.
And then now when you divided that by it, you should have gotten 0.9. So, long story short, this percentage should be 19.90%. And this is for boron 10, right? So how do we find the percentage for boron 11.
You do.
Subtract
You subtract. Now, there's two ways. What I would do, since you have this in percent form, I would subtract this number from 100, because then you have the percentage there. Theoretically, though, you could take this decimal form, plug it back up in here to 1 minus x, get another decimal, and then move it. But it'll be a lot easier just to take this percentage and subtract that into 100. So 100 minus this should give me 80.10% for boron 11. So at the end of the day, our two percentages, boron 10 exists 19.90% of the time. Boron 11 exists 80.1% of the time. Those are my 2% abundances. Okay.